Okay, class, we're about to start section 12.8, variation. We have direct variation. If y is equal to k times x, for some constant k, we say that y varies directly as x, or that y is proportional to x. We call k the variation constant, or the constant of proportionality. The equation y equals kx is called a direct variation equation. Okay, now it says a person drives d miles at 50 miles per hour for t hours. Find an equation for t and d. So we add distance. Distance is equal to the rate times the time. Now, we have the rate here, which would be 50 miles per hour. We don't have to put the mph. So it'll be d equals 50t. Now, what we want to do here, we want to know what k is actually equal to. Well, actually, k is actually 50. That's given to us. That is our constant. So k is actually the 50 miles per hour, or just 50. So now we have d equals 50 times t. We know r basically represents our k. But now we want to get t by itself. So this is how we would do. We would divide each side by 50. So we would have t is equal to d over 50. Now we could leave it as t is equal to d over 50, or we could rewrite this as t is equal to 150 times d. Now in this situation, if we wrote it as this, we would have our k would be equal to 1 over 50. So both of these are direct variation problems. Both of these are direct variation problems. So we could leave it as this, t equals 1 over 50 times d, or we could leave it as d is equal to 50 times t. Either one is fine. Does everyone follow that? Okay, now, exploration. It says the following graphs are of f of x equals 1/2 x, g of x equals x, and h of x is equal to 2x. Label each graph. Okay, now what we could do is this here. Let's take a look at these graphs in our calculator. Let me clear these out. Okay, I would say, well, let's put this. This would be 0.5x for the first one, because that's 1/2 x. Then the next one would just be x. And then finally, the third one would be 2x. Now we'll press graph. Now if you notice here with this graph, it's showing all three, right? But we still don't know which is which. So this is what you could do in your calculator. If you press y equal, if you press the right arrow, and let's scroll down to the other two. Press enter on that equal sign, and then enter on the second equal sign. If you notice, they're no longer highlighted. And then you can press graph. Now if you notice here, this 0.5 is the lower of the three. So that would mean that this is f of x is equal to 1/2 x. Now we could go back to the y equal, and then we could turn on the second graph. We could press enter on the equal sign and press graph. We notice that that is the middle. So that would be g of x is equal to x. And then finally, we could turn on the y sub 3 and then graph that. We know that this is the larger of the three. Starts going up faster than the rest. Okay, now, any questions on this? Okay, now it says changes in values of variables for direct variation. Assume that y varies directly as x with some positive variation constant k. If the value of x increases, then the value of y increases. Because remember, k is positive. If the value of x decreases, then the value of y decreases. Okay, now we go to example 2. It says the variable p varies directly as r, where r is equal to 2. If p is 5, when if p is 5, when r is 2, find the value of r when p is equal to 7. So we'll start this out. We have p is equal to k times r. Now, we will substitute in 5 for p, and we'll substitute in 2 for r. So we're basically solving for k. So we'll divide each side by 2, and we'll know that this is 2.5 is equal to k. So now, our new formula would be p is equal to 2.5 times r. Now they tell us that p is equal to 7. So now we can take our formula here and substitute in 7 for p, and then we can find r. We divide each side by 2.5, and then that will give us r is equal to 2.8, and that will be our final answer. Are there any questions from this problem? Okay, example 3. Suppose y varies directly as x squared. If y is equal to 8 when x is 2, find y when x is 1. So we have y is equal to kx squared. So now we will substitute. Y is 8 and x is 2. So we have 8 is equal to 4k. We divide each side by 4, and 2 is equal to k. So we have y is equal to 2x squared. Now we will go, it says find y when x is 1. So we'll substitute in 1 for x. And we will have 2 times 1. And so y is 2. So that would be our final answer for example 3. Okay, now we come to example 4. It says, suppose y varies directly as x and z. If y is 5 when x is 3 and z is 4, find y when x is 2 and z is 3. So we will have y is equal to k times x times z. So now we will substitute. Y is 5, k we don't know, x is 3, and z is 4. So we'll have 5 is equal to 12 times k. We'll divide each side by 12, and we will leave this as 5/12, because this will give us some repeating decimal. So we'll have y is equal to 5/12, which will replace k, times x times z. So now, we want to find y when x is 2 and z is 3. So this right here will end up giving us 5/2, which is 2.5. So y is 2.5. Are there any questions? Now remember, this 2 and 3 are over 1, so that's how I simplify out the 5/2. Okay, now we go to the next page. We're dealing now with inverse variation. Now with inverse variation, it says if y is equal to k over x for some non-zero constant k, we say that y varies inversely as x, or that y is inversely proportional to x. We call k the variation constant, or the constant of proportionality, which is the same thing we did for direct variation. The equation y equals k over x is called the inverse variation equation. Okay, so now the following graphs are of f of x equals 1 over x, and then g of x is 2 over x, and then h of x is 4 over x. So now we can put this in our calculator, and they want us to label each graph. So let's clear this out. So now we would take 1 divided by x. That'll be our first one. Second graph would be 2 divided by x. And the final graph would be 4 divided by x. Now let's just graph them all and see what they look like. I may have to do a zoom fit for this one. Yeah, it's not showing up. So I click on zoom and go down here to zoom fit. It's showing a little bit here. Now if you see here, these are overlapping here. So now we will go to y equals, and let's turn off the other two, like we did in the previous problem. We'll go to the equal sign in the other two and press enter, and then press graph. If you notice here, the 1 over x is the one that's closest to the origin. So we know that this first graph here, we know that this would be our f of x. Now I'm just going to put f of x here instead of the whole equation. You could put that if you want to put the whole equation. Okay, so now we go to the second one. We'll go down and enable the second graph and press graph. And you notice it's going above it a little bit. So this second graph will be g of x. Okay, but then last but not least, we'll go down to this 4 divided by x, press enter, press graph, and you notice it goes a little bit above that. So this would be h of x. Okay, so now, you scroll down here, assume that y varies inversely as x with some positive variation constant k. If the value of x increases, then the value of y decreases. Remember, they're inverses of each other. If the value of x decreases, then the value of y increases. Okay, now, come here to the next page. We have example 5. It says here the variable y varies inversely as x with positive variation constant k. If y is equal to 0.4 when x is 2.5, find the value of y when x is 4. So we have y equals k over x. So we have a value for y. We will substitute in 0.4 for y. We don't know what k is, but we know x is 2.5. So now, in order to solve for k, we have to multiply each side by 2.5. So we had 2.5 times 0.4, which would give us 1. So k would be equal to 1. So we will have y is equal to 1 over x. Now it says find the value of y when x is 4. So it would be y is equal to 1 over 4. And that will be our final answer. Or you could write down 0.25. Now we come to example 6. It says the weight of a body varies inversely as the square of its distance from the center of the earth. If the radius of the earth is 4,000 miles, how much would a 200-pound man weigh 1,000 miles above the surface of the earth? So we have W is equal to K over D squared. So we will have 200, which would be W, is equal to K over, it'll be 4,000 squared. Now, this would be 200 is equal to K over, it looks like 16 million. Now, we would have to multiply each side by 16 million. This is to get K. So this would give us 3,200,000,000 is equal to K. So now, we will have W is equal to 3,200,000,000. And that would be over, what's that, D squared.